Hello everybody. Today, let's take a dive into your car's 12-volt electrical system. So over the past 70 years or so, automobiles have gone through several changes, both good and bad. From those big rolling mountains of metal to the modern day computers on wheels, just about all the components in today's vehicles have changed, with the exception of that 12-volt car battery. That's right, believe it or not, the 12-volt lead-acid car battery has been the center of the car's electrical system since the 1950s. But with all of today's modern technology, including massive upgrades in battery chemistry, why are we still using that old 12-volt lead-acid battery? So before the 1950s, cars used a 6-volt battery. Back then, it was just enough to engage the electric starter and power some dimly lit headlights. But as cars grew bigger, they demanded larger engines, which in turn required more powerful electric starter motors. Also, more power was needed for those lighting features. Those dimly lit headlights were a bit hazardous at the time. Cars of the 1950s would also see added creature comforts that required electrical power, such as AM radio, interior lighting, and in some cases, even power adjustable seating and power windows. With a higher demand put on a car's electrical system, there was no way a 6-volt battery could handle it. So between 1955 and 1956, the 12-volt system was standardized across most passenger vehicles. Even with today's cars, whether you have an SUV, pickup, truck, car, an EV, or even a hybrid, the 12-volt lead-acid battery is still the center of attention for your car's electrical needs. So I guess the big questions are, why hasn't it changed in so long? Should it change? Will it change in the future? And are there any advantages of going to a higher voltage system? Before answering these questions, we just have to understand a little bit about electricity and the electrical demands a vehicle requires. So for reference, the term watts is the total power a component is going to need to work. For example, a starter motor may require 1500 watts to crank over the car's engine. Or the vehicle's stereo system may require 22 watts so you can hear it. The average 12-volt battery can produce enough power for the car's electrical components to work efficiently. It can easily produce enough watts for a vehicle's electrical demands. This is because the battery is constantly being charged by the alternator. That's the spinny thing in your engine. Another important term in regards to electricity is amps. The battery's amps are rated in amp hours, which is the amount of amps it produces in 1 hour. So a fully charged 48-hour battery produces 1 amp hour for 48 hours. This, however, is not so important since the battery is constantly being charged. But wait, didn't I say the starter required 1500 watts? Surely there's not enough power in a 12-volt battery to crank that engine, right? Well, these 12-volt batteries have a reserve known as cold cranking amps. This is the maximum output a battery can deliver while at 0 degrees Fahrenheit or negative 17 Celsius for 30 seconds without falling below 7.2 volts. Cold cranking amps can be anywhere between 400 to 1000 amps. So if your battery is rated at 500 cold cranking amps, it's possible to produce nearly 6,000 watts for a very short duration. Plenty of power to start your car. But before we move on, I guess we should discuss how power, or watts, is produced by the battery. We have to do a little bit of math, but don't worry, it's really easy. First off, I'm going to assume that we've heard the terms volts, amps, and watts. I'll break it down so it's a bit easier to understand, but simply put, amps is the current, or those little electrons needed to do the work. Voltage is the pressure moving that current back and forth in AC power and in one direction for DC power or battery power. Watts is the total power produced. So watts is simply voltage times amps. Now I know this is not the exact same thing, but let's compare volts and amps and watts to washing your car. Then we'll compare that to starting your car's engine. Well, that kind of seems fun, right? Let's try it out. Think of amps as the water you need to actually wash your car, and volts as the pressure of the water through the hose. Think of watts as the total amount of water that you're going to need to wash your car. So let's say your garden hose is equal to a 12-volt battery, and a pressure washer is equal to a 48-volt battery. And the wattage is equal to, I don't know, removing the dirt and the soap off your car. So let's say when using a hose, the amount of water needed to do the job of removing that dirt and soap is 10 gallons. Now we'll compare that to your 12-volt battery needing 125 amps to start the car. We use a simple calculation of volts times amps equals watts. So 12 volts times 125 amps equals 1500 watts, the amount the starter will need to do its job. Now, back to the water. By adding additional pressure from a pressure washer, the amount of water needed to remove the dirt and soap may be only 1 gallon of water because the water is under such tremendous pressure. Now we're going to compare that to a 48-volt battery. We're still going to need 1500 watts to start the car. But if we increase the pressure or we increase that voltage, the starter would only require approximately 32 cranking amps instead of that 125 amps. Remember, volts times amps. 48 times 32 equals 1500 watts. You may be thinking, who cares? What's the difference? Who gives a flying f***? My car works just fine the way it is. And for the most part, you'd be absolutely right. Which pretty much answers the first question. Why hasn't the battery changed in all of these years? Because it works. Why fix what ain't broken, right? Well, there's a little bit more to it than that. You would think that at least one car manufacturer would upgrade the 12-volt system, right? It would be just another way to soak its customers for more money. What a great idea, right? Well, not so fast. You see, it's quite a bit more complicated than that. You see, all of the accessories in your car use that 12-volt system, from lighting to wiper motors, seat adjustments, power windows, power mirrors. You get it. All of these systems are based on the 12-volt battery. It's the same way for every car, whether you have a car, a truck, an SUV, electric vehicle, hybrid, or whatever the hell passenger vehicle you decide to drive. To suddenly change that 12-volt system would be nearly impossible. Every single component ever produced and currently being produced uses 12 volts. So if you decide to use a 24 or 48-volt battery in your car, you would essentially fry every component, and that, folks, would make for a really bad day. With all that said, and everything working so well in 12-volt la-la land, will we ever see a higher voltage battery in passenger vehicles? With more and more components drawing power from the vehicle's electrical system instead of the hydraulic power produced by the car's engines, I think a larger battery such as a 24-volt system will eventually be needed. What's that you say?
You want my comments? What?
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 There's already a passenger vehicle which has a 48-volt battery? Really? What?
What?
Well, yes, there is. Can you guess what car or truck would have this 48-volt system? That's right, the Tesla Cybertruck. Whether you love it, whether you hate it, the Cybertruck uses the 48-volt battery to power all its accessories, not to be confused with its 125 kilowatt traction battery. This 48-volt lithium-ion battery is the center of attention when it comes to powering this big monster's electrical components. The Cybertruck has components that actually use the 48-volt system, such as that big motor for that huge wiper in the front, the steer-by-wire system, and its air conditioning system. Now, I'm not sure, but I do think there are additional pumps that also use the 48 volts as well. For the rest of its components, such as its lights, radio, infotainment system, power seats, etc., all that stuff, the Cybertruck uses 14 volts, so I'm sure there must be a transformer or some kind of component to step that voltage down. But all in all, the Tesla has completely abandoned the 12-volt system for its Cybertruck. So what are some of the advantages of increased voltage? The obvious one is more electrical components can be added. Although there are plenty of people out there who think we shouldn't make every single component electrical, such as brake-by-wire or steer-by-wire. That doesn't seem too safe. What happens if the electrical power fails? No steering and no brakes, right? But as we all know, changes are inevitable and they're a-coming. The second thing, a 48-volt system is more stable, with less flickering or dimming, and stronger starts in freezing cold winters. The third thing, with all the technology on the way, a stronger electrical system will be able to integrate these new tech packages without putting additional strain on an already loaded 12-volt system. The fourth thing, you can use thinner gauge wire. Increasing the voltage actually reduces the current needed, which causes less heat in the wires. Thinner wires equals less waste and more compact and organized engine bay. No need for those thicker cables. Have a look at this. The wires attached to a 12-volt battery, pretty thick. Now look at the wires attached to the Cybertruck battery. As you can see, a much thicker cable or wire is needed for the 12 volts, as opposed to these thinner wires in the Cybertruck. So in my opinion, I honestly don't think we'll see a mass upgrade in vehicles' 12-volt battery systems anytime soon. As of now, the 12-volt system seems to be good enough to power most of our luxurious cars, SUVs, and trucks. However, I can see a time, maybe 5 to 10 years out, where a 12-volt system may not be good enough. Now, 12 volts will never go away. Just think of those little interior light bulbs being powered by 48 volts. They're just gonna blow up. So vehicles with anything more than 12 or 14 volts, it's definitely gonna need a device to step down that voltage to make those little light bulbs work without blowing up, right? But for now, if it ain't broke, you get the point. Well, thank you so much for watching, folks. And as always, have a wonderful day.